Hello everyone. I hope you guys are doing good and staying safe. Welcome to Simplicode's YouTube channel, and in today's session, we'll be learning about another important data structure, which is stack. Now, stacks are one of the fundamental data structures in computer science, and they form the basis of many other data structures like queues and trees. By learning stacks, you can develop a better understanding of basic data structures and their applications, which have many real-world applications. So learning stacks can help you solve problems in all these areas and make you a more efficient programmer. They are often used in algorithms for tasks such as traversing a graph or finding the shortest path. So by learning stacks, you can actually improve your algorithmic thinking and become better at solving complex problems. So in today's session, we'll be learning all about stacks and how they are implemented. But before we begin, if you're new to the channel and haven't subscribed already, consider getting subscribed to our channel Simplicode to stay updated with all the latest content. And hit that bell icon to never miss an update from us. So without any further ado, let's get started with today's topic. So firstly, what is a stack? Stack is basically a linear data structure in which the insertion and deletion operations are performed at only one end. So in a stack, adding and removing of elements are performed at a single position, which is known as top. That means a new element is added at top of the stack. Now, daily life examples of stack that you can relate in your day-to-day life is, let's say, a pile of books, a deck of cards, a pile of coins as well. So all these examples allows you to perform operations from only one end. Like when you insert and remove, let's say, new books from the top of the stacks, it means insertion and deletion in the stack data structure can only be done from the top of the stack. And similarly, if you take the deck of cards, if you remove one card from the top, and if you place another one, that is insertion and removal will be only from one end. And similarly for pile of coins as well. So this is what a basic understanding of what a stack is all about. Now stack basically follows a specific order in which the operations are performed. Now it is called as LIFO, last in first out, or FILO, that is first in last out. So this is based on the principle of LIFO, which we generally say means the last element added to the stack is the first one to be removed. So in stack, elements are added and removed only from the top of the stack. That is, the element that is added the last will be taken out first. So the top of the stack basically refers to the most recently added element, and the bottom of the stack refers to the least recently added element. So that is what we are talking about. Next, let us discuss on what is representation of stacks. How can we represent a stack? Now, implementation of stack can be done by two methods. That is using a contiguous memory, which is arrays, and using a non-contiguous memory called linked list. Now we will discuss the implementation of stack using both arrays and linked list in our execution part at the end. So stay tuned to that, where we'll understand how to write the syntax for stack and what is the logic behind the stack implementation using arrays and linked list. Alright, let us now move ahead and discuss how does a stack work. Now basically in a stack, elements are added and removed only from the top of the stack as we discussed. So if you look at the stack here, we have 5 elements, 10, 20, 30, 40 and 50. So the element at the top, that is 10, is known as the top of the stack element, and it is removed from this only. So elements are added and removed only from the top of the stack. So the top of the stack refers to the most recently added element. So even if you look at this example, we have a stack of 5 elements, 50, 40, 30, 20 and 10. I'm just taking an example here, which is the top element is 50. Now I am pushing 50 here. So we do not have any element in this position. So we are basically adding or pushing the element 50 at the top of the stack. Now let us understand peak in the next slide, where we'll understand what peak is. So for now, let us understand what the stack of the top or the push is all about. So as discussed earlier, operations on stack. Now in stack, elements are added and removed only from the top of the stack. Now there are basically 4 operations that are performed on the stack. Sorry, 3 operations, which are push, pop and peak. So let us now discuss about them in detail. So what is a push operation in stack? So a push operations involves inserting new elements in the stack. Since you have only one end to insert a unique element on top of the stack, it inserts the new element at the top of the stack. So if you look at this example that I've taken here, we have a single element 10 and then I'm pushing another element 20. So the stack becomes 10 and 20. And similarly, we are pushing each an element until we insert a total of 5 elements till 50. Now, once we insert all this element, the element at the topmost is called as the top of the stack element. Now, similarly, we have pop operation as well. Now, pop operation refers to removing the element, which is in contrast to the push operation, which adds the element at the top. So, it will basically remove the element from the stack again, since you have only one end to the uh, top of the stack. So removing an element from top of the stack is termed as pop operation in stack. So in this example, since we had 10, 20, 30, 40, 50 in our stack, I am removing the topmost element, which is in the top of the stack, which is 50. Then it becomes 10, 20, 30, 40. Now similarly, I'm removing 40 as well, and then I'm removing 30, and finally 20 as well. So this is basically the pop operation where we are removing element from the top of the stack. Now we also have peak operation. Peak operation basically refers to retrieving the topmost element in the stack without removing it from the collection of data elements. So we will understand it in a more better way when we get into the execution part. So I hope you understood the basics of what stack is, what are the how it is represented, and what are some basic operations that are performed on stack. So let us now directly jump into my Windows Visual Studio Code and let us perform some examples on stack. So as you can see, Visual Studio Code has started. Now, firstly, let us discuss the example of implementing stacks using an array. Now, a stack can be implemented using arrays by using a fixed size array to store the elements of the stack and then keeping track of the index of the top of the stack. So let's now follow the code and see how it is implemented. So firstly, we have to create an array with a fixed size to represent the stack. So the code for that would be mention the header files, which is hash include IO stream using namespace std. And then we have to define a stack, array size, right? So for that, I'm basically using a class here. So I'm taking class stack, and inside that I'm creating a private member function, and I'm defining the array here. So int the array name is arr array and mention the size. So let's take the size as 1000. It can be of any size depending on the number of operations or variables that you are taking. Assign it accordingly. And then we have to mention the int top. All right. Next, we have to see whether the stack is empty or not. So for that, we will write another code here inside the class only, where we will give a public function and we are calling the stack function which you have taken here member. So inside that, I am assigning top to -1. Now you might get a question why we are assigning top to -1 here. So the top of the stack is represented by an index that basically points to the last element inserted in the stack. So initially, the top of the stack is set to -1 here, indicating that the stack is empty. So when an element is pushed onto the stack, it is inserted at the top of the stack by incrementing the top index by 1. So let us see how it is done. So let us now take another function here, which is void. And since we want to insert element, I am just taking a function name push, and I am taking a parameter integer. I am trying to pass an element of variable x. So inside that, I have to write a condition here. So basically, we are checking if the stack is empty or not. So if a stack is greater than the maximum size, then we say it is stack overflow. And similarly, if the top value is less than 0, we say it is underflow. And if top is equal to 0, we say stack is empty. So that is what we have to run here. So to check if the stack is full, we basically check the top of the index variable is equals to the size of the array -1. So that is what I'm going to write here. That is if top is greater than equals to the size that we have taken 1000 -1, okay, and we basically retrieve the value saying cout, saying it is an error. That is, stack is overflow. Stack is overflow, and we will end the line. Then we will return the value. All right, and then we will increment the value to, we will initiate array and we will increment this value to top. So top plus top equals to x. So I hope you've cleared till this line here. So we have inserted an element. So when an element is popped from the stack instead of pushed, it is removed from the top of the stack by decrementing the top index. So for that we have to write the pop, for the code for pop as well. So I'm taking another variable of int saying int pop, wherein if top is less than 0, then we will consider it as underflow. Alright, so it will throw an error saying stack is underflow. Alright, and we'll basically end this line and return -1. Now, I know it is a bit of confusing, guys, so let's just implement this and I'll explain at the end what is the concept that is being lying and why we are taking this here. So let's just move ahead and let us write int x is equals to array of top. Alright, and then I'm returning the value. Return x. Alright. Now you can also implement peek function as well. Peek basically inserts the top of the element without removing it. So for that also you can implement. So I'm just taking another value int peek. So for peek, what I'm saying is if top is less than 0, okay, we will say the stack is empty. So mention that cout stack is empty. So we'll close this and in line you can keep it, and we will return -1. And similarly we will assign the value to the array, which is int x equals to array of top. Right, and return x. Finally we are retrieving the value, and similarly we are also checking whether the stack is empty or not. So for that I'm taking a bool expression, which is we use isEmpty method in order to check whether the stack is empty or not. So return top if it is less than 0. Alright, so this is basically the code for pushing, popping and the peek operations in stack. So now all we are left with is to call the main function. So I'm just taking a main function here and I'm trying to insert values. I am taking stack s. So for push s dot push is the method. I'm inserting 1, and similarly s dot push 2, similarly s dot push 3. Alright, so I think we are good to go, and we have to retrieve values, right? So cout, I am using s dot pop function. It says popped from stack. Okay, so the values that we are trying to remove from the stack will be shown here. So next, cout for we have to also find the top element. If you want to find the top element, for you can use that also. So I'm just taking cout top element is, and I'm calling the value that we have taken, which is s dot peak. You can end the line or you can leave it as such. And finally, we will return 0. All right. So this is basically the code to how to implement stack, guys. So let us just execute this and we'll see the output. So click on run and it will take some time to finalize the output. So as you can see in the output, it says 3 is popped from the stack and the top element is 2. Now we have inserted 3 elements here, 1, 2, 3. So the order of stack will be 3, 2, 1, the 3 being the top of the stack. Now we are popping the element 3 from the top of the stack, so it becomes only 1 and 2. Now the top element becomes 2. Now to just summarize what we have done here, this implementation of stack using an array is done by creating an array to store the stack elements, where the top variable keeps track of the index of the top element of the stack here. So if you take here int top is basically keeping track of the index of top element of the stack. Now next we have created a push function here. Push function inserts an element at the top of the stack, and similarly we have a pop function, removes and returns the top element of the stack. And similarly we have also created a peak function which will return the top element of the stack without removing it. And we have also taken is empty, which will check basically if the stack is empty or not. So I hope you understood using how to implement stacks using an array. So let us now move ahead and discuss how to implement a stack using a linked list. All right. So let's just clear this. Now I think it will be a time-taking process, guys. So I'll just copy paste the code for linked list. So I'll just explain what is the process being done so that you'll have a clear idea as well. So as you can see, I have returned the code for implementation of stacks using linked list here. So the implementation basically uses a single linked list here to store the stack elements. So each node of the linked list contains an integer data here. So if you look at, we have created a class here basically of stack node, and we have created a public member function. Inside that we are assigning int data value. So which is basic, each node of the linked list contains an integer data and a pointer next to the next node of the list. So you can see here we have passed the value of int data and we are pointing a value to the next node in the list. So the top variable we have called here, the top variable is a pointer to the top node of the stack. So basically the push function basically inserts a value into our linked list here. We have created a function void push and we are passing the value in data. And this is the code where the new node stores the data of the next node and we are storing it as the top function. So the push function inserts a new node at the top of the stack since we are assigning the new node to the top value. Similarly, the pop function removes and returns the top element of the stack. The code is also similar to that. We are just checking if the stack is empty. Now, if the stack is empty, we will return it as stack underflow and will return -1. So the peak function also similar to that, returns the top element without removing it, and it is also, we are also using isEmpty function which checks if the stack is empty or not here, and if it is empty, it will return -1. And finally, we are passing the main function and adding some values into that. And similarly, we are checking which is the element that is being removed from the stack, and after removing, what will be the top element present in that stack. So this is just a basic idea of what how stack is implemented using a linked list. I hope it is clear. Now we will leave the code in the description below so you can check that out. And if you have any queries while implementing, you can let us know in the comments. We will try to figure it out and explain it to what we are doing there. So let's just execute this and we'll see the output. So again, as you can see, 3 is popped from stack. Since we have inserted 3 elements, 1, 2, 3, the order will be 3, 2, 1. So the top of the stack element is 3, it will be removed. Now the top element becomes 2. So in this way, you can use, similarly, it is almost same to that of arrays, guys. So if you have a clear understanding of what, how arrays and linked list works, you will have a clear-cut idea on stacks also on how to implement them. So if you want to have a detailed knowledge on that, we have a separate video which we have created earlier on linked list and arrays. So make sure you check that out. So with that, we have come to the end of today's session, guys. I hope you have covered pretty much all about stacks, how to implement them using arrays and linked list. Thank you for watching the video, guys. If you found this tutorial informative and helpful, give it a thumbs up and share it with your friends. If you have any further queries regarding any of the topics covered in today's session, feel free to let us know in the comment section below, and a team of experts will be more than happy to help resolve all your queries at the earliest. Stay tuned to the channel for more such amazing content. Until next time, thank you and keep coding.